gravity. It's a big deal. It's one of the fundamental forces of nature that shapes our universe. Gravity keeps us on the ground, making sure we don't float away into space. It's the reason why we can walk, run, and jump without drifting off. It makes a ball fall back down when you throw it, ensuring that what goes up must come down. This simple action is a daily reminder of gravity's presence. Gravity even controls how planets move, keeping them in their orbits around the sun. Without gravity, the planets would drift aimlessly through space. A long time ago, a smart guy named Isaac Newton figured out that gravity is a pulling force between things that have mass. The famous story of the apple falling from the tree inspired his groundbreaking ideas. His idea explained how planets orbit and stuff, but it wasn't perfect. Newton's laws worked well for most things, but there were some mysteries they couldn't solve. Then, about 100 years ago, Albert Einstein came along and changed everything with his theory of general relativity. Einstein's theory provided a new way to understand gravity. Einstein said gravity isn't a pull, but a curve in space and time caused by heavy objects. This was a revolutionary idea that changed our understanding of the universe. Imagine a bowling ball on a trampoline. It makes the trampoline dip down, right? This is similar to how massive objects like planets and stars warp the fabric of space-time. Einstein said big objects do the same thing to space and time, and other objects follow those curves. This explains why planets orbit stars and why we stay grounded on Earth. That's what we feel as gravity. It's the curvature of space-time that keeps us anchored to the ground and governs the motion of celestial bodies. Einstein's theory fixed the problems with Newton's idea and opened up a whole new world of space exploration. It allowed us to understand black holes, the expansion of the universe, and even the possibility of time travel. Einstein's big idea, general relativity. Einstein's theory in 1915 changed how we think about gravity. He said gravity isn't a force from far away, but something built into space and time. Heavy objects warp space-time, making a curve that tells things how to move. That curve is what we experience as gravity. General relativity even predicted things like gravitational waves, which scientists later discovered. These waves give us clues about the biggest, most exciting events in the universe. Gravitational waves, ripples in space. When really heavy things speed up, they make ripples in space-time called gravitational waves. These waves travel as fast as light, stretching and squeezing space as they go. They're not like light or sound waves, they're ripples in space itself. Even the biggest explosions in space make waves that are super faint and hard to find here on Earth. But studying them tells us about crazy places in space like black holes and neutron stars. Big explosions in space making gravitational waves. Huge explosions in space make gravitational waves that travel through space-time. When black holes crash into each other, they make huge waves that we can detect even billions of light years away. When neutron stars crash, they make bright explosions called kilonovas and powerful gravitational waves. Even exploding stars and spinning neutron stars make these waves. These waves show us the most powerful and energetic things happening in the universe. By finding these waves, we learn about gravity and the crazy events happening in space. Gravitational waves give us a new way to explore the universe's biggest moments. Black hole tango making waves. When two black holes orbit each other, they create a cosmic dance, sending out gravitational waves. As they get closer, their gravity gets stronger, making bigger waves. This goes on until they finally crash together, creating a huge burst of energy. This final burst is the strongest source of gravitational waves we know. Finding these waves proves black holes exist and tells us about these extreme places in space. Studying these crashes helps us learn about gravity and what happens to matter in extreme conditions. These cosmic dances give us a special look at the universe's most extreme events. Neutron, star, crash, fireworks and waves. Neutron stars are some of the densest things in the universe. When they crash, they create a huge explosion called a kilonova and send out powerful gravitational waves. Unlike black holes, neutron star crashes also create all sorts of light that we can see. This gives us lots of information about what happens to matter when it's packed super tightly, and even about how the universe is expanding. Studying these crashes tells us about neutron stars and where heavy elements come from. We are learning about these cosmic events by looking at both the waves and the light they create. Listening to the universe. Finding gravitational waves. Finding gravitational waves was really hard. Early attempts weren't sensitive enough. Then, scientists built laser interferometers in the 1990s to measure tiny changes in distance caused by these waves. LIGO, a team of scientists from Caltech and MIT, became really good at this. In 2015, LIGO found gravitational waves from crashing black holes for the first time. This was a huge moment that proved Einstein was right and started a new era in astronomy. It was a brand new way to explore the universe. LIGO. Seeing with sound, the Laser Interferometer Gravitational Wave Observatory, or LIGO, is a marvel of modern science. It allows us to detect the faintest ripples in the fabric of space-time, known as gravitational waves. LIGO has two detectors, one in Louisiana and one in Washington. These twin observatories work in unison to capture these elusive waves, providing us with a new way to observe the cosmos. They opened a new way to see the universe. Unlike traditional telescopes that rely on light, LIGO uses sound to hear the universe, giving us insights that were previously unimaginable. Each detector has long arms with mirrors inside special vacuum chambers. These arms stretch out for kilometers, creating a highly sensitive instrument capable of detecting minute changes. When a gravitational wave passes by, it changes the length of these arms just a tiny bit. This change is smaller than the width of a proton, yet LIGO can measure it with incredible precision. LIGO can measure these tiny changes, showing that a gravitational wave went by. Scientists then analyze this data to understand the cosmic events that cause these waves. LIGO is so sensitive it can find waves from billions of light years away. This means we can study events that happened long before our solar system even existed. Since 2015, LIGO and another detector called Virgo have found many gravitational waves. These discoveries have opened up a new era in astrophysics, allowing us to explore the universe in ways we never thought possible. This tells us about black holes, neutron stars, and how the universe has changed over time. By studying these waves, we can learn about the most violent and energetic processes in the universe, shedding light on the mysteries of our cosmos. Gravitational waves. Unlocking the universe's secrets. Gravitational waves give us a new way to look at the universe and learn its secrets. These ripples in space-time, first predicted by Albert Einstein over a century ago, are now being detected by advanced observatories like LIGO and Virgo. Unlike light, these waves travel straight through everything, carrying information from far away. They move at the speed of light, but they are not hindered by matter, allowing them to bring us pristine data from the most violent events in the cosmos. They tell us about extreme places like crashing black holes and neutron stars. When these massive objects collide, they send out gravitational waves that ripple across the universe, reaching us billions of years later. By studying these waves, we learn about where they came from and even about the very beginning of the universe. The echoes of the Big Bang itself might be detected, giving us clues about the birth of everything we know. Gravitational wave astronomy is new, but it has already changed what we know about space. The first detection in 2015 opened a new window on the universe, and since then, dozens of events have been recorded. As our detectors get better, we'll discover even more. Future upgrades and new observatories will allow us to detect fainter and more distant events, expanding our understanding of the cosmos. This field is changing how we understand the universe and our place in it. The data we gather from gravitational waves complements what we learn from light, giving us a fuller picture of the universe's history and structure. The universe used to be silent, but now we can hear its symphony, and it's changing everything. Each new detection is like a new note in a cosmic melody, revealing the hidden dynamics of the universe.